Okay, good afternoon, everybody. We are joined today on our quarterly Digital Foundry Tech Talk Tuesday with a couple of special guests from CESMII. And CESMII is the Clean Energy Smart Manufacturing Innovation Institute that is in partnership with the Department of Energy. And our guests who are joining us today are Haresh Malkani, who is the Chief Technology Officer for CESMII. Haresh oversees the technology mission, roadmaps, and objectives of CESMII, and he will be spearheading a lot of the development and technology spanning everything from sensors and controls to data analytics and modeling for manufacturing and smart applications. Haresh comes to his role at CESMII with over 30 years of experience in the industry, particularly in industrial R&D environment with Arconic and Alcoa. Where he was responsible for the development and deployment of many smart manufacturing technologies. He holds a PhD and an MS in mechanical engineering from Northwestern and a BS in mechanical engineering from, and I'm going to butcher the name of your undergraduate university, Haresh, so you may want to just say it.
You're on mute.
Maharaja. Okay. Haresh, we have you. Okay. So we'll move on to Howard Goldberg. Howard is the Chief Operating Officer for CESMII, responsible for ensuring that all aspects of their headquarter and SMIC operations are managed to their objectives, including everything from operations, accounting and financing to their compliance and resourcing to support their projects and initiatives. Howard also brings many years of experience in the industry. He has over 20 years of leadership in successfully growing businesses and operations on leading edge sensors technologies, and most recently was the Executive Vice President of Operations for Pressure Profile and the developer of tactile sensors that enabled sense of touch for electronic products. Howard also holds a PhD and an MS in electrical engineering from the University of Michigan and a BS in electrical engineering from Lehigh University. So, gentlemen, thank you so much for taking time out of your day to talk with us today. And I'd like to start with allowing each of you to give a brief kind of perspective on who CESMII is and a little bit of the history of the organization as you see it. So Howard, do you want to start?
Sure. Well, pleasure to be here, Sherry. Thank you again. So CESMII is the United States Institute on Smart Manufacturing. So our mission is to drive the cultural and technological aspects of what we call smart manufacturing. So that is taking the industrial Internet of Things and sensors, and more importantly, getting the data out of that to drive energy productivity, operational efficiency through small to large manufacturing throughout the US. So to help them improve the bottom line with operational efficiency, energy productivity, predictive maintenance, things like that. So we're founded in 2016 in a partnership with the Department of Energy, the US government, and we're the third institute that the DOE had started up. And right now we're one of 16 institutes under the Manufacturing USA umbrella. And our program and administrative home is here in UCLA in sunny California. And we have about $140 million of total funding, half of which is cash from the DOE. The other half is co-investment from our partners over a 5-year period of time. So we're excited to be here, and we're trying to evangelize smart manufacturing throughout the US.
So Haresh, you want to add anything to that? I know you have a long history with CESMII, both not only as an employee, but as a member company perspective. So would you like to add anything about CESMII?
Sure. Thank you, Sherry. Thanks for the introduction. Sorry, I was muted earlier on. Yeah, I think the journey for CESMII actually began almost, I would say, 15 years ago. In fact, this is like the 15th year that we are celebrating the onset of smart manufacturing in the United States. And if you go back 10, 15 years, the movement for smart manufacturing began with a few of these workshops that were taking place between, some of the government organizations as well as industry. It began there. The seeds were planted there. And then there was an organization called the Smart Manufacturing Leadership Coalition, which brought together some of the thought leaders in this space. That came about as a coalition that started talking about what smart manufacturing is, what the needs are across the industry. And then that was the organization that actually first got the application going with the Department of Energy for this institute. And following that, a couple of years later, UCLA became the home for this institute. So that's a history, a little bit of a history behind that. Again, the mission has been the same. It's now to the point where the institute has sort of moved on from becoming a coalition to actually executing on a large portfolio of projects to actually looking at now outcomes that can be used and reused by the industry. So.
Okay, thanks for the perspective. So I'm going to ask you a question now that's, I think if you ask 10 people, even 10 people who know smart manufacturing, you're going to get 10 different answers. But I'd like to hear from each of you. How do you define what smart manufacturing is? And why is it important to industry to be paying attention to this subject right now? Haresh, you want to start with that one?
Sure. And you're right. I think depending on who you talk to, you'll get different answers. I think smart manufacturing at a very basic level is the leveraging of information to make smart decisions. Okay, those decisions can be made by human beings. They can be made by devices. They can be made by machines. They could be made at the enterprise level, right? So depending on what viewpoint you have. But the idea is to take information and then leverage that to make decisions. Now, it's easier said than done in the sense that, yes, that's a basic concept, but in order to get the right information, you have to have the right sensors, right? You need to know what your process is doing today. So that's about sensors. The next big thing is that raw data is very rarely useful, right? So now you got to take that raw data, convert it into some actionable information. Then the next step is to actually do some analytics on it, understand why things are happening. Then you go from there to saying, well, now that I know why things are happening, can I actually predict it? Then you get into the predictive side of things. You start doing some process modeling, predictive modeling, whether that's data-driven, which is all machine learning and AI kind of thing. But you also have subject matter expertise that develop physics-based first principles models that help you predict what's going to happen next. And then the end point of that is to bring all that stuff down to a segment of this ecosystem where you can actually take actions. A human who's perhaps an operator or an engineer can make a decision, or a control system that can make a decision. So that's the world of smart manufacturing. And depending on your size of the organization, what you do, what industry you are in, you may start focusing on different aspects of that. Because flow of information can be that entire loop, or it could just be a segment of that. So depending on what your needs are.
Right. Great. So Howard, do you want to add anything to that on your definition?
Sure. Yeah, just to build upon that. So as Haresh said, it's finding the critical points in your process to take a sensor measurement, whether that's temperature for a chemical process or maybe pressure for a metal stamping process, sensorizing the process, collecting the data. But as Haresh said too, it's important to take the data, analyze it, and then take an action to improve process control or process efficiency. So to optimize the process so there's less waste or scrap or less use of labor, or predictive analytics to make sure your machine uptime so you don't have any downtime on machines, which costs money. So all these have an impact on the financial bottom line to manufacturers, and also energy consumption, because really energy is a indirect component of every product we make, and that's why we're funded by the DOE. And by doing things smarter, especially in the US, that's how the US manufacturers are going to better compete on the global stage. And we're not going to win just by throwing more labor at it to ship more product. we have to do things smarter. And this can apply at many levels. It could be local, so a single plant can sensorize our process, operate more efficiently. Maybe a related groups with several plants in a large company, or maybe a supply chain are sensorized together to operate as a cohesive unit. Or nationally and globally, as all manufacturing gets smarter, we improve the global supply chain so we can avoid, like we saw with COVID, some of the supply chain impacts by having supply chains be smarter, more reactive, and reducing the carbon footprint. So we're all, by all manufacturing being more efficient, more smarter, they're using less energy to make a unit product. So there's less carbon emissions and we get greener along the way as well. So it's, so it's important at many different levels, I think.
Right. And I think you both made a very distinct point. We call it smart manufacturing. And it's not just about the technology. You can implement a lot of technology and it can still be dumb. It has to lead to that you're making better decisions, that you're adding business value, that technology is being leveraged to deliver something that has an impact. So hence the word smart, right? So that's an important part of it, is not just that you're using the technology, but that you're using the technology to make better decisions. So next question, and I'm going to direct this to you, Howard, is speak to me a little bit about the education and workforce development, as well as the affinity groups, some of these things that you have in place to really be a resource to your target audience in both the businesses associated with the affinity groups and the workforce.
Sure, I'll be glad to. So the person who heads up our education workforce development, great guy, Conrad Leva. But education is an important part of it. As we just spoke, smart manufacturing has a lot of technology to it, and that's important. But the current workforce and future workforce has to learn how to use the technology. So manufacturers today use a wrench. Manufacturers of the future will use a touchpad or dealing with data. But there'll be more data analysis than having a wrench on a production line. So we got to train the current workforce, upskill them, as well as train the future workforce. So education is a big part of what we do, and we have to target the whole ecosystem, from students, the future workforce, to system integrators in the field today, manufacturers, professional practitioners, and the business leaders of the companies. And we just conducted a market survey with SME, and we found the biggest gap or concern for most companies that they want smart manufacturing, but they need to educate their current workforce to get there. So having this type of training is important, and training the whole ecosystem. And we train through several modalities because there's no one size fits all. So we have e-learning, webinars, videos, in-person classes, workshops. We do the training directly through CESMII under Conrad's group, as well as with partners like yourself at Penn State, the SMIC that'll be there, NextGen, SME with their tooling university. So we do that through some sponsored partners as well. So people can see a lot of what we're doing through our member portal or our website. So we have a listing of all our webinars and our catalogs, but we do try to do the whole spectrum, and we have to train from factory floor level to engineers all the way up to the C-suite executives on how to use smart manufacturing, understand the ROI and benefit of what it's giving them. And so in terms of affinity groups, that's one of the things we offer our members. So what an affinity group is a group of CESMII members that come together with a particular interest, typically aligned around an industry vertical like aerospace or food, but also could be a technology horizontal. And they, as a group, collaboratively define what's the key issue that they want to solve in their vertical or horizontal, and how can smart manufacturing and CESMII's toolbox help them get there. So we help them run the meetings and help them decide, do they need EWD, do they need the platform, do they need technology, and allows them to come together. And sometimes you have several competitors within the industry sitting at the table solving some common problems. Well, that's kind of the beauty of CESMII, is this public-private partnership, this collaboration is kind of the win-win. The rising tides raises all the boats, but you have competitors that are collaborating together to solve industry-wide problems. So currently we have 3 affinity groups: food and beverage and community consumer packaged goods is one, aerospace, and small to mid-sized manufacturers, but we're looking to grow that, and they're all member-driven. But it's kind of part of EWD and getting hands-on involved. As we say, when you join CESMII, it's a full contact sport, and affinity groups is one of the ways that members can get involved to contribute to CESMII.
Thank you, Howard, for that background. So you talked a little bit about the kind of those human networks and human development side of SESMII. But Haresh, I want to ask you a little bit about the technology side. You do a lot of co-funded research that was mentioned a little bit already, but you also do a lot of this through what you call your SMIP, your Smart Manufacturing Innovation Platform, and some of your smart manufacturing profiles. So talk to me about those vehicles for getting the technology in the hands of your members. And
Yeah, sure. One of the things that we didn't explicitly mention is what every institute that was formed through this public-private means has a roadmap that kind of defines how we take our investments and then drive towards the goals of the institute. So the roadmap has, I would say, three major segments which kind of drive our investment strategy on how co-funded research takes place, right? So one is around what we're calling enabling technologies. So if you have hard problems that you're trying to solve in things like sensing or control or analytics or modeling, the second piece is around the platform. And this is where you're trying to solve the problem not for one segment or one use case, but do it in a fashion where the solutions become available to a large ecosystem of manufacturers, right? It's all about reuse. And the third piece is about workforce development, right? So we do funded research for developing the curriculum and then having that curriculum be used by the talent pipeline or the existing workforce. So the roadmap essentially identifies the areas that we want to go after, and then we create what are called requests for proposals. And then the teams are formed. The folks who respond to those RFPs are basically teams that's made up of it could be a combination of the manufacturer, a systems integrator, a software solution provider, academia, and they come together and say, here's our proposal to solve this problem, and then we kind of do the selection, review, and so on and so forth. So our investments are kind of in those three buckets, and so far we've got about I think there are 55 projects in our portfolio, and they all have sort of a distributed investment strategy in all of these areas that I just mentioned.
And in those three areas, do you have a certain one that is kind of dominant, or how's your split across those three types of projects?
They're pretty evenly split. I think earlier on we were focusing more on the long-term projects because you need enough runway for them to actually solve a really hard problem. So one example might be in steel manufacturing, for example, there isn't a good set of sensors that can withstand the harsh environment. Well, that takes a little bit of a development. So we wanted to take some of the larger projects and launch them earlier on, and then move on to some of the shorter term projects. So we actually now have a portfolio of about 25 plus 6-month projects, which are delivering value to the manufacturer fairly quickly, right? So we have a transition between those. Education and workforce development projects tend to be about a year. So we launched them. Some of them were launched earlier on. In fact, Penn State was one of them. And then there have been several in the last couple of years that we've launched, which would then come to completion.
So tell me a little bit about the SMIP and your SM profiles and how those show up for.
Yeah, sure. So I mentioned that, the idea is not to solve a point problem and then be done with it, right? We want to make sure that whatever we are doing becomes reusable by our community. And one of the fundamental ways in which we make that happen is through our platform technology. So the SMIP, a SMIP, is the Smart Manufacturing Innovation Platform. And a central theme in that platform is something called an SM profile, the Smart Manufacturing Profile. So the profile is a structured information model that describes the asset or the process. So let's say you have a stamping press or you have a chemical process that you're trying to improve. And the profile then defines what are the critical attributes of that process or that machine that need to be measured and then predicted, right? So if you take a predictive maintenance application, the profile then defines what are the key sensor requirements that you have, and it also defines what are the predictive variables that you need to be able to come up with. Now, once that profile is defined, it becomes part of our marketplace. And then from the marketplace, other manufacturers who have similar processes can just take those profiles, build them into the solution so that they don't have to do all the grunt work of actually creating that information model. Today, what happens is that every solution that is created starts from scratch, and we want to prevent that. So the marketplace would allow doing that. And the same thing with the applications. So if you've created a predictive maintenance application for a hydraulic press, that becomes available in the marketplace. And then you can take the profile, the predictive model, combine them together, and then create the solution that you need.
So how does this overlap or complement solutions that are being developed commercially in those spaces?
I'll respond first, and then I'll ask Howard to add color to that. I think one of the, it's not, we don't see this as a competition. What we're trying to do is actually enable those solution providers to actually expand their footprint through these. So the more standardized we get on creating these types of information models and applications, the more leverage they have with a wider ecosystem, right? Mm-hmm. Otherwise, what happens is that you have markets where larger companies that can afford specialized systems will be able to march down this journey faster, but then the small and medium manufacturers don't have that benefit. So we're trying to enable the entire ecosystem, including system integrators, software system providers, so they can come together and do this at a broader scale, right? And we are creating a lot of interfaces that allow some of the solution providers to use these technologies, without any issues.
Right. Yeah.
Yeah, totally agree with Haresh. And so we're trying to break down the barriers. That there are solutions out there, but they're more siloized, and there's a lot of vendor locks. If you have one solution with a vendor A, you can't interact with someone that uses vendor B, or there's not a lot of interoperability, harmonization, especially globally. So we're also working a lot with Industry 4.0 in Germany, because manufacturing is global, and Germany's been one of the leaders on the European front. So trying to come up with common standards and common, as Haresh said, machine profiles that can be shared across different platforms to really bridge this gap and kind of, not to overuse the word, but democratize things, much like the iPhone or the smartphones have democratized apps and allow people to share across different platforms. So there are solutions out there, but they're very siloized, and they're a lot of vendor lock and not a lot of harmonization, interoperability.
Right. Yeah, makes a lot of sense. So moving on then, we've talked about SMIPs. Now let's talk about SMICs. So another SESMII acronym is your SMICs, your Smart Manufacturing Innovation Centers. So you have described yourselves as a network of networks, and SMICs are a part of that. So maybe Howard, you can start with describing a little bit about what a SMIC is and how you work through that network.
Sure. Well, you can't be a government-funded entity without a 3 or 4-letter acronym. So I think we checked that box. But so SMICs are lighthouse extensions of SESMII. So as you know, SESMII, we're headquartered here in LA out of UCLA, but our mandate's to cover the entire US. So we have to cover the whole footprint geography-wise, and for all industries and all company sizes. So can't just do it from the West Coast here in LA. So we need lighthouse extensions of partners, and proud to say that Penn State is one of our newest SMICs. So we have 7 SMICs and 3 satellites today that cover the country. And what they are, like I said, lighthouse extension, but their partners are we selected them because they're already up and running. They had a focus on an industry that's strategic to us, or a technology horizontal that was related to smart manufacturing. They already had play and traction in smart manufacturing, already had relationships with industry and assets that could be connected to our platform, as Haresh described, so we can demonstrate and teach on smart manufacturing. So we picked partners that are already kind of up and running in smart manufacturing and kind of brought them into the SESMII way of doing it. And what it does for our members, it allows members to be able to go to a local SMIC to be a sandbox for them to understand what smart manufacturing is. We can engage them on where they are in their journey. It might be, they're just starting off or in the middle or towards the end, but engage them wherever they're at and help them get to the next step and to make it more real to them and lower any barriers. If they have a technology barrier, help them work it through it. If it's an education and workforce development barrier, help them work it through it as well. And what we do for our vendor community members is create technology sandboxes. So if you're an app vendor, you can come plug into our platform connected to an asset at the Penn State SMIC, for example, and demonstrate how your app can solve smart manufacturing challenges. The same if you're an EWD partner, if you have a great training program that we can endorse, we can run that through one of our SMICs as well. So, all the training we do, all the technology demonstration, we do out of headquarters, but anything we do in headquarters, we can do at any one of the SMICs as well. So that's kind of the goal is the SMICs is to be the lighthouse extension of CESMII, and to better integrate into SMM, small to mid-sized manufacturers. We're also working pretty hard to align the MEPs, the manufacturing extension partnerships that each state has, at least one of them, and they're funded by NIST, but they have deep relation with small to mid-sized manufacturers. So we're aligning our SMICs. We have all this SM content with the MEPs, our conduits, SMMs, to try to get the SMMs more engaged as well. So again, the network of networks, as you said.
So Haresh, still on that topic of SMICs, and it's a little bit of a different model compared to some of the other institutes that were established across the country. You have more of a kind of a centralized hub and more of a physical footprint where they're centralized. So what do you think the advantage is to your model, which is a little unique, of having your your physical assets spread across the country in these network organizations?
Yeah. Well, I think because the institute is kind of founded to address a more of a cross-cutting need, it's probably better for us to have this network of networks where we can say that in order for us to work on technologies and train people that are associated with, say, the small manufacturing community, then it makes sense to have somebody who specializes in those. You have the right kind of assets in your physical facility. You have the right kind of people that can train those smaller ecosystems. It's kind of hard to say that, okay, if we have a single physical asset that can sort of demonstrate and address all of these areas that we've been talking about, it just, it's physically impossible. The advantage of having these smart manufacturing innovation centers across the country is, like Howard was saying, that we can address some of the regional strengths, whether it's in the academia or whether it's in the manufacturers or the software providers, and then also address the industry segments. So you might have, food and like metals manufacturing, for example, is all in the Midwest mostly, right? So we have centers that are focused on that. You might have the food industry or paper industry that's more on the southeast side. You have the aerospace industry on the west side. So we are able to actually reach out to the entire ecosystem through these innovation centers, and which would be impossible to do with one single location.
So before we move on to my next question, I see we have a question in the Q&A from Luke. Does CESMII also have relationships with industry organizations working in the same space, such as the International Society of Automation?
Yeah, so we do. It's not a formal relationship, but the ISA as an organization was how historically automation has taken place, right? So we do have a lot of systems that are still tied to that architecture. There's a lot of legacy work that is being done, and our thought is not to just completely rip and replace, right? The idea is to blend that into this new way of doing things, which is the Industry 4.0 method. So we have to have close relationships with the folks who are working on the ISA model, the systems integrators who are still embedded into the way things are done using that architecture, but then slowly transition into something that is more flexible and more cost effective and so on. So we have to have that connection. I think the systems integrators are probably the community that's the closest to us, that's allowing us to maintain that connection with.
Right. And everybody thinks kind of about ISA, the pyramid, right?
Right.
And the different levels of automation, but the SMART is bringing in that element of tying those levels together so that you send data up the pyramid and decisions back down, right? So,
and even the ISA model is sort of transitioning, right? I mean, as the technology providers are sort of blending some of those layers anyway, so you can't really plug them into one layer, right? And which is a great thing, because you're sort of moving on to more of a sort of a blended responsibilities and functionalities.
right.
And similarly, we're engaged with CSIA, the Control System Integrator Association. Our CEO, John Dyke, spoke at one of their events a week or so ago. SME, Society of Manufacturing Engineers, been around for over 100 years. But to Haresh's point, it's all about partnerships. It's all about partnerships and getting the message out to them, working collaboratively at many different levels. So SESMII just can't do it alone.
Right. Thanks for the question, Luke. So my next question for Howard and Haresh, if you could each provide a good example of something that stands out in your mind as a great success story for SESMII, on whether it was a technology project that delivered great results, or a training program where you got some tremendous impacts. But tell us a little bit about one example that jumps out to you of a success story.
Howard, do you want to start with something?
Yeah, sure. I'll start with the SMIC side, and I know Haresh has a lot of great projects to pick from. But on the SMIC side, all our SMICs are great. Probably the one that sticks out was North Carolina State University. So with that SMIC, they have 4 departmental assets. They have a biomanufacturing facility where pharmaceutical companies come and prototype drugs or pre-prototype drugs. So it's a clean room. And with those assets are connected to our platform. Pulp and paper, which is a big industry in the Southeast, as Haresh said. So they have a full pilot production pulp and paper plant that's instrumented, that's connected to our platform. A non-wovens facility. So they make the N95 masks and things like that, things that use synthetic fibers. And then lastly, they have a new facility coming online, advanced manufacturing, 3D printers and robotics. So all those departmental assets are connected to the platform. So we can show the platform OT/IT, bridging that gap aspect. But more importantly, it set the stage to do training. We're doing training on these assets, but these assets weren't fully smart, so to speak. So now they're smart, and now we can add the training with SESMII. We can add that training dimension of smart plus the training they're doing. So they were doing training students to be the next generation of pulp and paper engineers, and in the pulp and paper facility. And in the biomanufacturing, they had a lot of industry training going on, training people from the top pharmaceutical companies. Now they can train them on the smart aspect of that as well. So to me, that was one key thing that stood out, and fully demonstrates the power of the SMIC and what we're trying to do here.
And from a project standpoint, I think 3 projects that I'm going to just highlight, in one for each of the areas that I mentioned before. So if you look at the segment that we're calling the enabling technologies, where you're actually going after a very hard problem, this one happens to be in a very energy intensive industry, the cement industry. So we had a team that identified the problem as they have these clinker production has these long kilns. They basically process the material through these large kilns, but the behavior of that piece of equipment is not very well known. And so as a result, what happens is that they set the operating set points of that kiln to be much higher than what's actually required, and therefore there's a lot of wasted energy. So what they did is they created a lab scale kiln. They instrumented it, they created the sensing modules, they created the process models, they brought it around and said, okay, here's a optimized control system for it. And they were able to reduce the energy consumption by 15% in the lab. And now they're taking it to one of the cement manufacturers who's a partner on a team and implement it there. So that's one. And that happens to be in an energy intensive, large industry kind of segment. The second one is a small manufacturer in upstate New York who makes nutrition bars. And this is a great success story because, it's a very small organization. They didn't have a lot of exposure to things like sensing and smart manufacturing and all that stuff. And the team came together. They instrumented. One of the problems they're seeing is a quality problem with the nutrition bar that they make, where it's not consistent because of the way the cooling process is controlled. And so they instrumented that with just very simple, low-cost sensors. They looked at the data. They make the changes to the operating set points. They were able to find out where exactly to locate the sensors in this process, because that's a learning that they did as well, and huge benefits from there. And within 3 months, they were able to demonstrate the value of that by saying that their quality has gone up significantly. And within 3 months, they've been able to show significant improvement in the product that they make, right? So again, and that's a small manufacturer story. It's a great story to tell. And the third one is workforce development. I'm going to pick on the project that we did with Penn State, which was one of the first projects that we did for workforce development. Great success story. Again, a benchtop device that Penn State and MIT came up with. That benchtop device is being used to create the curriculum and the software modules that become part of the curriculum, teach the students on how a small device, which represents a large manufacturing process, how can that be controlled in an optimized fashion using smart manufacturing technologies. And that has a dual impact, not only the look and feel of how that's done, but also how you blend that the components into a learning program. And I believe you've had 2 or 3 semesters of success with the students in doing that. So those would be the 3 that I would highlight.
Well, thanks for that shameless plug, Haresh, for what we're doing at Penn State New Kensington and the Digital Foundry. We are thrilled to be one of your newest SMICs, and we will be offering that level 3 smart manufacturing training you just mentioned again for incumbent workers in June. As you said, it's already being used in our classrooms, and we did our first cohort of industry participants last year. And they said the second one coming up in June. So we agree it's a great kind of simulation for teaching the concepts of smart manufacturing.
Absolutely. Yeah.
So tell me what each of you sees as some of your key goals for CESMII, and particularly how you want to leverage those goals for those that you serve.
It's a good question. I think we like to make smart manufacturing as pervasive as, ISO 9001 and lean manufacturing. I remember when those first came out, everyone wanted to do some of that, but wasn't quite sure how to get there. And once they adopted it, it kind of transformed the industry. And so I think we see smart manufacturing is kind of the same. We can see in the future where maybe students get certified in smart manufacturing, or you become a black belt, green belt kind of equivalent in smart manufacturing. So getting that as pervasive as that, and in fact, we're seeing some ways to leverage lean manufacturing and smart manufacturing as an entree to do training with SMMs. But anyway, so make it pervasive as that to help make U.S. manufacturing competitive on the global stage. Yeah, but doing it in a way where we meet companies where they're at in their journey, recognizing each person's at an individual place in their journey. There's no one size that fits all. We're not a vendor, so we're not trying to sell one approach or one product. And so kind of at the membership level, that's what I like to see us do. Kind of at the institute level, ensure that CESMII is further seen as the smart manufacturing institute, the flag bearer of smart manufacturing in the USA. We think the U.S. needs a flag bearer, just like Germany has Platform Industry 4.0, and individual companies kind of have one flag bearer. The USA maybe doesn't quite have one yet, and we want to establish CESMII as that. And we think the advantage of doing that is that being a public-private partnership, we can do what no one company and one state government can do on its own. And we can bring competitors at the table to help make their industry better. With those 2 competitors naturally wouldn't interact outside of CESMII. So to kind of be able to do the 1 + 1 = 3 kind of stuff, that's kind of unique with a public-private partnership. So at least that's from my side, that's what I'd like to see.
How about you, Haresh? What do you think are some of your key goals to help advance CESMII and those that you serve?
Yeah. When we started the Institute, we had a set of metrics that kind of defined what our goals were going to be. So if you look at those metrics, there are two metrics that are specifically for making an impact in manufacturing through things like energy productivity and efficiency, operational efficiency. There's a couple of metrics that are around how do you make smart manufacturing accessible for everybody. So it's about the adoption of smart manufacturing, lowering the cost of adopting smart manufacturing solutions. And the third set of objectives that are around workforce development, right? So, and again, if you heard us today, you'll get a sense of how we are trying to address each of those segments in different ways, right? So our goals are kind of tied to those metrics. And if we haven't made an impact across the system for all types of manufacturers, then we would consider ourselves as a failure, right? We have to do that. And in order for us to do that, we have to address each of those barriers in a fashion that we can not only prove it in one case, but prove it and proliferate it for the entire ecosystem. So it's not just sufficient to solve one case. You have to have a way to do that in sort of a reuse and proliferation. And we are at a point in our institute right now, we are in our 5th budget period, and we've moved very rapidly from execution to an outcomes-based approach now for the remaining period, so that whatever we do as an institute has to be reusable across the system. That's really the primary goal from our standpoint.
Right. Get the most bang for the buck, right? So we have another question that came in from Mike, and he's asking, are there any other current education projects let's see, I lost my place, underway that will introduce younger students like middle school and high school to smart manufacturing? It's a great question.
So we are, Conrad's working right now. We are looking to, it's in the planning phase now, but looking to do some boot camps with some, starting first, probably in the LA area, some community colleges that service those STEM high schools. So to kind of do those, smart manufacturing one-on-one boot camps. And we're also looking at potentially some hackathons to kind of get that younger generation involved. So it's still in the planning phase, but stay tuned, I think, in the next 2 or 3 months to be more on that front. I'll go a little off the top of my head here, and I'll need Haresh's support, but we're trying to refresh my memory on the El Camino CSUN project. I know they got to the college level. Do you remember if that got down to the high school level or not in its curriculum?
It did not, but I think one of the things that happens in many of these cases is that they serve as locations where a lot of high school students come and visit, right? So then through that exposure, they get to know about the programs that are being run at the college level, but then I think they have some opportunities for having, co-ops and sort of internships during their high school tenure as well. So,
and I can comment on, for us at the Digital Foundry, that's an important audience for us, is and through some of the relationships that Penn State New Kensington has developed with K through 12 school districts in our region, we intend to be an asset to those school districts. We are already doing some programming with high school students, and as Haresh and Howard indicated, being a SMIC and with the activities that we have going on there, we intend to bring students into the space, give them an introduction, raise awareness of what's some of these trends that are going on in industry. And also, we're starting to already look at how we take some of the content that we've built for our workforce training and put that into some of our summer camps and things like that we're doing for high school students, because they're certainly more than capable of grasping some of these concepts and understanding it. Most of them grew up carrying smart devices around in their hands from the time they were toddlers, so they probably get it better than a lot of us do. So sure. Yes, that's important to be investing in that next generation for sure. So we don't have any other questions that have come up in the chat, but we'll wait and see if we get a few more. But in that interim, I wanted to ask a little bit from the two of you about an upcoming event that we're very excited about, because it's being hosted right here in Pittsburgh. It's the Smart Manufacturing Experience Conference that is co-hosted by SESMII and SME, the Society for Manufacturing Engineers. It will be held in Pittsburgh, June 7th through the 9th. So I wanted to ask if you could talk a little bit about what people can expect to experience at the conference and at the exhibits, and in particular, I know SESMII will have a large presence there. So tell us a little bit about what participants can see if they come out to this event in June.
Sure. No, we're very excited about the event too. So this event integrates the Smart Manufacturing Experience Conference and Exhibition by SME with SESMI's annual member meeting. So we typically hold an annual member meeting where we provide the latest updates to our members on the project status, the platform, EWD, and kind of the state of the art from our perspective, what's going on in smart manufacturing. So by being part of this, it gives us a larger venue to disseminate that knowledge. So we have SESMII involved with the keynotes, conference tracks, presentations in the exhibition hall. We have a big exhibition booth. A lot of our members are there. So we can do things on a broader venue, talk to the broader manufacturing ecosystem from large to small manufacturers. And we think it'll be a key event, especially for SMMs to come about to make the goal of, at least from our aspect of the event, is to make smart manufacturing more accessible for SMMs, small to mid-sized manufacturers. So I give them a lot of quick how-tos and guide them through the process where I know it can be sometimes daunting when they look at it from the outside in. So, we're quite excited about this event, and I'll let Haresh add to that. But.
Yeah, we have a fairly large footprint on the floor where some of the technologies will also be demonstrated. So, there's going to be a fairly significant set of demonstrations that we will do with our Smart Manufacturing Innovation Platform. We will have presence of most of the SMICs there, so they have a special segment where they can highlight what's going on in that arena. We also have a space for our MEPs, which is the Manufacturing Extension Partnerships, to come and represent their organizations as part of our SESMII footprint there. We'll have a partner of ours, Ametrol, is also bringing in a physical asset. Again, it's sort of a benchtop kind of thing. But again, those are types of things that you can sort of touch and feel and see how smart manufacturing technologies can make an impact on manufacturing. And plus, we'll have several projects represented in things like rolling slides and just specific outcomes that we've had from some of the projects as well. So yeah, not to miss. It's
quite excited about this.
Yeah.
Okay, well, any other last questions for our panelists before we bring this to a close? All right, well, we thank you all for joining us for the Digital Foundry's Tech Talk Tuesdays. Stay tuned, join us on our website or on social media, follow us on social media. Stay tuned for more events to come, and our next Tech Talk Tuesday will be coming out this summer. We look forward to seeing you then. Howard and Haresh, thank you very much for your time today, and thank you very much for your partnership with us. We're looking forward to many good things to come.
Yeah, we have to. Thank you for having us.
Thank you for having us.
Yep.
Bye.
Take care.